Now we're going to discuss summarizing and graphing data. And what we're going to use is frequency distributions to illustrate collections of large data sets. A frequency distribution shows how a data set is partitioned by listing all the categories for that data set and how many values are in each category. So for example, let's say we had a collection of a bunch of female pulse rates from the low 60s to 124. We might separate these into classes of pulse rates in the 60s, and pulse rates in the 70s, and pulse rates in the 80s, and so on. And a frequency distribution would look like this. There's our pulse rates on the left column, 60 to 69, 70 to 79, 80 to 89, and so on. And the frequency is how many of those pulse rates are in each category. So for example, the first category, 60 to 69, it says that the frequency is 12. That must mean that above that, in that data set, there are 12 instances of pulse rates in the 60 to 69 category. And there must be 14 data points in the 70 to 79 category. So if we added up all of the data points that we saw in the 70 to 79 category, we should get 14. None of them, apparently, are in the 110 to 119 pulse rates. And something interesting to note is there are 40 female pulse rates here listed. We could add up all of the data points, or we could add up the frequency in each one, 12 plus 14 plus 11 plus 1 plus 1 plus 0 plus 1, and that should also equal to 40. Let's zoom in on that first couple of pulse rates. First, vocabulary, classes, 60 to 69, 70 to 79, 80 to 89. We refer to those as the classes. And the lower numbers, the 70, the 60, those are what we call the lower class limits. The 79 and the 69 and so on, those are what we call the upper class limits. Some more vocabulary with this. Class boundaries. You're going to be asked to calculate class boundaries. A class boundary is the number that is in between the upper class limit and the lower class limit of two consecutive classes. So for example, if we're looking at the first two, between 69 and 70, the upper class limit of the first one and the lower class limit of the next one, the number that's halfway between 69 and 70 is 69 and a half. That would be the class boundary. Likewise, if you go to the second two, the number that's between 79 and the next one, 80, is 79.5. So if we were to calculate all of the class boundaries, we would get the 69.5, 79.5, 89.5, and so on. And the two that are easy to forget are the class boundaries for the lowest part, which is 59.5, and the highest part, which is above 129, so 129.5. The next thing that we're going to want to calculate are class midpoints. Class midpoint is the number that's in the middle of a class. To find the class midpoint, you can do it by inspection. So the number in the middle of 60 and 69 is 64 and a half. But if you would like to calculate that, you just simply add the upper class and the lower class limits together and divide by 2. So between 60 and 69, you get 64.5, 70 and 79, you get 74.5, and so on. And then finally is the class width. The class width is the difference between two consecutive lower class boundaries. So again, if we're still looking at the first two rows, that would be the difference between 70 and 60. So 70 minus 60 is 10. 80 minus 70 is also 10. 90 minus 80 is 10. So our class width is 10. That's an easy one to get confused. The class width is not 69 minus 60. It's not 9. That's a common mistake people make. Okay, let's do another example. So here's a frequency distribution. We have 4 classes, 10 to 13, 14 to 17, 18 to 21, 22 to 25, and the frequency how many data points were in each of those classes. So there were 312 instances of a data points that were between 10 and 13. And let's figure out the following: lower class limits and upper class limits, class boundaries and midpoints, and the width. Well, the lower class limits are pretty easy. Those are just the smaller numbers in those intervals, 10 and 14, 18 and 21. I'm sorry, 18 and 22. And the upper class limits are the bigger parts of the intervals, so 13, 17, 21, and 25. Now the class boundaries, remember, those are the numbers between the two classes. So between 13 and 14 is 13.5. Between 17 and 18 is 17.5. Between 21 and 22 is 21.5. And don't forget the lowest one and the highest one. So just below 10 would be 9.5 and just above 25 would be 25.5. Class midpoints, that's halfway between each of the classes. So remember, we're going to either find the middle number between 13 and 10 or add them together. 10 plus 13 is 23 and divide by 2. So 11.5, 15.5, 19.5, and so on. And finally, the width. Don't forget, you're not subtracting for the width of each class 13 minus 10. You're doing 14 minus 10, the lower class limit of 2 consecutive classes. So 14 minus 10 and 18 minus 14 and 22 minus 18. Of course, all the class widths should be the same number. Okay, next topic, relative frequency distribution. If you have a frequency distribution like we have on the left here, remember to figure out what the total number of data points was. We just need to add up each frequency. The frequency represents the number of data points in each class. So if we calculate 2 plus 3 plus 4 plus 3, we get 12. That should be the total number of data points in the original data. We're going to need that number to figure out the relative frequency. So for the class 60 to 64, the relative frequency is what percent of the data appeared in that class. Well, if 2 data points out of 12 appeared in the first class, the relative frequency is 2 divided by 12, 0.167, or 16.7%. And the next one would be 3 divided by 12. So there are 3 data points in the next set divided by the total, which is 12. And we get 0.25 or 25%. You might want to look at your homework system. Some of them want the answers listed as percents, and some of them want the answers listed as decimals. You just kind of have to adapt from question to question or textbook to textbook. Okay, calculating the rest of these, we get 33.3 and 25. And these percentages should all add up to about 100%. If there were no rounding whatsoever, it would add up to 100%, but there's usually a little bit of round off error here. Okay, next is cumulative frequency distribution. This is figuring out how many data points are below a certain level. So for example, if we're looking at that same frequency distribution on the left-hand side, and we want to find the cumulative frequency distribution for each class, the first class, everything lower than 65, well, there's only 2 data points that are smaller than 65. But if we're looking for all of the data points that are less than 70, that would be 2 plus 3 more. So that would be a cumulative frequency of 5 that are smaller than 70. To find all the data points smaller than 75, we would take 2 plus 3 plus 4, which would give us 9. And then finally, 2 plus 3 plus 4 plus 3 is 12, and that should be all of our data points are smaller than 80. There we go. Normal frequency distribution. The frequencies in a normal frequency distribution do the following. They start small, they grow bigger, and then they get small again, and they do it in roughly a symmetric pattern. So if you look at these two frequency distributions here, the one on the left and the one on the right, I want you to notice they both kind of start small, get bigger, and then get small again. However, the one on the left starts much smaller than it ends up. It starts small, it gets much bigger, and then it doesn't really taper off very much. The one on the right-hand side, however, starts small, grows bigger, and then pretty much goes as small as it started, back down to 1. So we would say that the frequency distribution on the right-hand side is a normal frequency distribution, but the one on the left-hand side is not.